In this video, we're going to figure out how to derive the formula for binomial probability. But we're going to start off with a particular problem. In this case, a cereal company is offering collectible cards as prizes. 20% of the boxes of cereal have a card that features LeBron James. If you were to buy 5 boxes, the question is, what is the probability that you would get exactly 2 boxes with LeBron James cards? So that is a seemingly straightforward question to answer if you know anything about probability theory. And what I recommend is that if you think this is a simple problem to solve, pause the video right now and take a moment or two or 5 or 10 and see if you can calculate on your own without any further research, just using your intuition. See if you can calculate the probability. All right. Now, a couple of things may have happened if you just pause the video. Is one, either you think you figured out the probability, and maybe you got the answer wrong. You'll see in a minute. And then the other possibility is maybe you have no idea what to do, and you're thinking, "Wow, this is a challenging problem." I believe that that is the situation for most people, that this is a challenging problem. And so we're going to walk through some strategies for solving this together. The first thing that you might think of is that if you're talking about getting two get 2 boxes with LeBron James cards, you might say to yourself, well, the probability of getting 1 box with a LeBron James card is 0.2. And if we think about the probability of getting 1 box and another box, you may recall that when we say we typically multiply probabilities. And if you're really an advanced probability student, you would realize that we also have to take into account the probabilities of getting boxes that don't have LeBron James, because we say exactly 2, not 2 or more. So we're assuming that these guys are not going to be LeBron James, and we figure that out by doing 1 minus 0.2. That gets us the probability of not having a LeBron James. So if you were a fairly advanced probability student, you would suspect that this would be the multiplication that would be required to get the answer. And you're close. If that's what you thought, you're doing great. But there is one little problem with this, is that this assumes that we got a 1 LeBron James and then got another LeBron James and then got all boxes without LeBron James in that specific order. The reality is it's entirely possible that we could have gotten no LeBron James, and then we could have gotten a LeBron James and a LeBron James, and then no LeBron James, and one more no LeBron James. So this is also a possibility. Now again, for those of you that understand probability, you might say, okay, well, we either could get this or we could get this, and therefore I could go ahead and just add those guys together. And if that's what you're thinking, then you're headed in the right direction. Again, the only problem is we have to do this a few more times. So then the question becomes, well, how many times do we have to do this? And one way to do that is to write out all possibilities. Now, we didn't talk about what the other sports cards are, and we don't need to. In this case, since we're discussing binomial probability involves either a failure or a success. And so we'll treat getting a LeBron card as a success and anything else as a failure. And in that regard, we could write out all the possibilities. So we could say that we get a LeBron. In this case, we want 2 LeBrons. So we could say we get a LeBron and a LeBron, and then something else and something else and something else. And then we could keep rearranging this. We could say, well, we get a LeBron and then not a LeBron, and then a LeBron and then a couple more that are not. We could also get a situation like this. And we could just continue to write these out until we've written out all possibilities. And what I'd like you to do is I'd like you to finish this. Why don't you go ahead and pause the video and write out all the possible ways that we could get 2 LeBrons and then 3 other cards that are not LeBrons. Okay, so I wrote out the rest of the possibilities here, and I have 10 total, and I hope that's what you got. Now, I want to point something out to you, is that there's another way to approach this. Maybe you have seen something like this before. What I'm writing out, do you remember what the name of this is? I'll let you pause the video and think about it, just in case you want to recall it on your own. And if you've paused the video, I'll go ahead and tell you what this is right now. This is known as Pascal's Triangle. And Pascal's Triangle, it has a kind of a magical relationship to what we're working on right now. It turns out that these 10 possibilities for this binomial, for these LeBron cereal box things, it's directly related to this part of the Pascal's Triangle. And let me show you how it is. It turns out that you can write out, I'm going to go ahead and write out a bunch of combinations here really quickly. So here's the point that I'd like to try to convey to you is I believe that this list of combinations that I have listed here, or choose functions, I believe that this forms Pascal's triangle. You'll get Pascal's triangle out to this particular level 1331. What I'd like you to do right now with your calculator is calculate these C's and make sure that you believe me that this is 1 and this is 3 and this is 3 and this is 1. Go ahead and try these, but go ahead and pause the video and try these on your calculator. And if you do, we're going to go ahead and extend our knowledge of Pascal's triangle to help us figure out exactly how many different ways we could have things arranged in a variety of different situations. All right, if you're still with me, then hopefully you've verified that this is really 1331. If you believe that's true, what I'd like you to do is I'd like you to try to figure out what is the C of what, comma, what, that is associated with this 10. Now, I'm not asking you to get the number 10. I'm asking you if you believe that this is the same as this triangle here. I'm asking you to figure out at what part of what is the C, what C of what comma what represents this position. Not the value 10, but what represents this position. Go ahead and pause the video and see if you can fill in this and this. And I'll be back in a moment. Okay, I'm hopeful that you agree with me that what you'll put here is 5, comma 2. And if that's the case, we're going to try to relate this directly back to the problem that we have here. It turns out that this 5 represents the total number of trials that we're interested in. In this case, we're interested in how many boxes of cereal we buy, and so we'll call buying each box of cereal a trial. The 2 represents the number of successes. And when we're talking about binomial settings, the number of there's either successes or failures. So that's how this is related to binomial probability. So this is number of trials, this is number of successes. I'm going to go ahead and I'm going to take this information, we're going to put it together, and we're going to say that what we can say at this point is if we have C of 5, comma 2, That's the total number of ways that these can be arranged. In other words, this is one arrangement, and this is one arrangement. That's two arrangements. We believe we're going to have this total number of arrangements, which in this case turns out to be 10. But the C52 lets us do this for any number of boxes and any number of successes. So we will multiply this times this other stuff. And it turns out the other stuff, well, we have 0.2 multiplied times itself. So we'll call that 0.2 squared. And then we have 0.8 multiplied times itself 3 times. So that's 0.8 cubed. And then the next thing we're going to do is we're going to go ahead and find the general. This is the formula for binomial probability, but this is for this specific situation. Now we're going to go ahead and generalize based on this formula. So let's take a look at that. In order to generalize, in order to take this specific formula and make it general, we need some definitions. So we're going to call n the number of trials, which that's not too surprising to us. We've seen that in the past. We'll call p, a lowercase p, the probability of a success, and x will equal the number of successes. And by the way, in this case, our x, if we buy 5 boxes of cereal, our x, which is also a random variable, it is our random variable, it could have the value 0 or 1 or 2 or 3 or 4 or 5. In this case, we just happen to only be concerned with this particular value, but x is a random variable and it could take on any of these values, because if we buy 5 boxes of cereal, we could get 0 or 1 or 2 or 3 or 4 or 5 with LeBron James. Anyways, let's continue on. I will define one other variable, and we'll call that q, lowercase q, and that'll be the probability of failure. Now, we don't really have to define this variable. This variable is simply equal to 1 minus p. Since it's a binomial situation and you either have success or failure, 1 minus p would be the probability of failure, since p is probability of success. Even so, for now, we'll define a q. So let's go ahead and put it all together. And our general formula for binomial probability will now be, remember 5 was the number of trials or the number of cereal boxes? So we'll go ahead and put n there. And 2 was the number of successes. We were curious about what would the probability of having 2 LeBron Jameses was. So we'll put x here. And then we'll multiply that times 0.2 is our probability of success. So we'll say multiply that times lowercase p. We'll raise lowercase p to the power of 2, which is again the number of number of successes that we're looking for. So we'll raise that to the power of x. And then we'll take the lowercase q, which is the probability of failure, which is the 0.8, and we will raise that to the power of, it'll be the number of trials minus the number of successes. So it'll be n minus x. And by doing that, we have established a general formula that we can use to compute binomial probabilities. So if we wanted to figure out the probabilities associated with x for each of these, we could go ahead and do it using this formula. For each of these values, 0 and 1 and 3 and 4 and 5, we could go ahead and calculate that. Oh, and before I forget, for those of you that wanted to confirm what the value was of the probability here, it should have come out to be about 0.2048, or about 20.5%. So just wanted to let you have that in case, who knows, maybe you were one of the lucky few who figured that out on your own before you were taught any of this.